Well, let me explain this rather simple circuit to you and why I'm recording it at night or early in the morning before the sun is up. You see this black cylinder? That's a cardboard tube, and on the left end we have a red LED, and on the right end we have a photoresistor. So I have this Raspberry Pi Pico, and its input is this yellow button, and the output is this. Well, the output is the red LED that's right there on the left end of this black tube. And I'm going to tell you what I tried to do was make an optocoupler circuit here, a homemade thing. I had an LED and over here a photoresistor, and they were exposed and they worked well, except there was always light coming in through the window. And so this the output, so this photoresistor is acting as the base signal, the signal to the base to this little transistor there. And here's a separate isolated 5-volt DC power supply. So this Raspberry Pi circuit and that LED are completely electrically isolated from this circuitry here. We don't need that capacitor. The photoresistor. Anyway, this is what's going to happen. So I've been following a YouTube channel called Global Science Project. I'll get it right after. And the work the guy is doing is very interesting to me, having some academic background in this neurophysiology and neuropsychology and how the brain works and that kind of thing. And electronics, of course, an electronics hobbyist. And anyway, this thing was working well. It was supposed to simulate a neuron. Anyway, you have the transmitting neuron here. So this is the terminal button that's sending the transmitter fluid, in this case photons, light, to the terminal button on the receiving neuron. And it's just an experiment. So I thought, you know, what if I'm getting this ambient light and it's introducing a signal to this transistor? Why don't I look around and find something I can completely block all light? So I took this, I found a little cardboard cylinder, tiny, like a paper towel roll, but cardboard. Yeah, I wrapped it in electrical tape, but I also have some black polymer clay, and I'll show you that after. I'll take it out. And so there is no light, I'm sure zero light, getting into this tube. So the LED will turn on and the light will hit the photoresistor and turn on the LED, which it does. But here's the problem now, that this is a new problem. Okay, I'm going to press the button, light goes on, great, but look, I let my finger off the button, but the light is still on. It wasn't on before, right? So we know the resistance of that photoresistor was very high to not send a signal to the base of this NPN transistor, small signal transistor, sufficient to allow the current to flow through the emitter collector. Look, it's still on. See, I have to turn off this light. Yeah, look. Why? Why is the photoresistor in that tube still conducting? What's the latency there? It's something I did not notice. I'm showing you this because I didn't notice it before I put these two components in this tube. And that's the phenomenon that I posting this video about. That light is still on, so that means what? There's either a latency in the reuptake. I call it reuptake because that's a term they would use in physiology, the reuptake of the transmitter substance. Of course, we don't have a transmitter substance here like dopamine or any of the other ones. But what we do have is light. So is it the LED that's still putting out some infrared, maybe, in the form of heat? I don't know. Or is it something to do with the photoresistor that just slowly goes back to its zero state? Maybe somebody out there can help me. I'm trying to find something on using Google, and I'm not really getting the results I want. I'll turn that on again. You can see what's going on here. I'll only turn on for a moment. It should turn off immediately. Turns on, turns off. But look, it doesn't turn off. It stays on. At first I thought there was some kind of capacitor going on, something slow discharge. But of course I built the circuit. There is no capacitor, but you know, what's going on? What's going on in that tube is the question. Is it infrared that's hitting the photoresistor? Infrared as a result of the slight heat generated in that little contained space where the LED resides? Or is it something to do with the photoresistor? I just don't know. Look how long it stays on. That's unacceptable for this experiment. I have to figure out something. You know, I may break down and just buy an optocoupler for $2, but you know, that would be surrender. Show you this optical isolator I built. I wanted a way to isolate the entire interaction between the LED on this end and a photoresistor on this end, so that when the LED turns on, the resistance of the photoresistor goes down, allowing a slight amount of current to flow through it and provide the signal to the base of a small NPN signal transistor. So I just happened to find this miniature cardboard tube. What was in it? I don't remember. Wire? I have no idea. I just don't remember. Probably very old, sitting in my, parts box. And I thought that's just the perfect thing. So I situated the LED in there and I bent the legs down. And this black, I have polymer clay, Sculpey, and I happen to have black polymer clay. I didn't go out and buy it, but there it was. And I stuffed it in there. And I did the same thing on the photoresistor end. So these are the legs of the photoresistor. The photoresistor is sort of bent in there, and they're sort of in there facing each other. The LED is pointing this way, and the photoresistor is here, and it's looking at the LED. So the LED turns on, red light travels here and hits the photoresistor. This, yeah, so I baked it in the oven for 20 minutes at 170 degrees, thereabouts, Fahrenheit. And it hardened the clay. So now the clay is hard. It's a polymer and it's very hard. And at that low temperature doesn't damage the components at all. So they continue to work. And I did test them against, I have other red diodes and photoresistors, so I could test that. So this nice little unit here, I thought that's just a great little feat of engineering. But no, now I have another problem. And I didn't have the problem before I made this little unit, and that was the LED turns on, and the photoresistor allows current to flow, and the light on the secondary circuit turns on. And then I release the button, the LED turns off, and the light on the secondary circuit turns off, mostly. There was ambient light getting in, and that was, I wanted to eliminate that, and this was the perfect way. I definitely did eliminate ambient light, but now this photoresistor, I guess it's on this one, this end, the legs are longer. The photoresistor doesn't turn off right away, and it bugs me.